Welcome to Kenton's videos. Enjoy the video.
You start by confirming prerequisites and taking the first actionable steps. Pick a flight controller that supports GPS and a compatible GPS plus compass module. This is the sensor core. Mount the GPS on a dedicated mast, away from power wires, because magnetic interference breaks heading. Next, wire ESCs and motors to the controller, double-check motor direction now. It saves time later. Make sure battery, power distribution, and telemetry are connected. Once done, power the system briefly to confirm basic telemetry and lead heartbeats. Now you configure firmware and sensors step by step. Flash a stable build like ArduPilot or PX4, then connect to your ground control station to edit parameters. This is where features live. Calibrate accelerometer and gyro on a perfectly level surface, then do compass calibration while rotating the airframe. Improper calibration causes drift. Calibrate ESCs so throttle and points match. Verify the GPS acquires at least 6 satellites and lock. Once achieved, enable GPS flight modes and perform short hovers to validate behavior and basic PID response. You finish by validating safety and functionality before full missions. Set fail-safes, low battery, RC loss, and a safe RTL altitude. This prevents catastrophic loss. Conduct incremental test flights, first hover, then position hold, then a short waypoint mission, while recording logs. If something goes wrong, don't panic. Review the telemetry and log files to identify yaw drift, vibration, or GPS anomalies. Rerun calibrations, isolate wiring issues, replace the GPS or compass if interference persists. Keep iterations small until
Thanks for watching. Consider subscribing if we helped you.